Thanks. I can see 34 people are in the meeting, so it's great to see all of you. I'm going to be joined by colleagues from the committee. Tom should be on. Is Tom on the line? I think he is. I think Tom Moore.
Yeah, good afternoon. I'm here as well, Stuart.
Yeah, and I think Felix might be joining at some point as well. So, well, hello. Hi, Tom. Yeah, I think Felix is joining at some point, and oh, it's got a lot of background from someone. Oh, there we are. Right, thank you. Yeah, Felix will be joining soon as well. So the point about today's session really is myself, Tom, and Felix have been on the committee and seen a number of railway challenges. I was there right at the start. I was University of Birmingham, were one of the founding teams when we tried the challenge. I think it was in 2012, the first year that we did it. So between us all, we've got a huge amount of experience of seeing what goes well and what goes wrong, and the aim of this meeting really is for us to sort of give you a bit of guidance and inspiration, tell you some of the things that give you some guidance and advice and hints and tips, if you like, on what makes a good team, and then what makes a team, what the sort of pitfalls are where things go wrong. Our aim and what we'd like to see is you all building successful locomotives and entering the challenge and arriving with a working locomotive and leaving with a working locomotive with big smiles on your face. Obviously you'll all want to win as well, and not all of you can do that, but I think that a major achievement will be arriving with a good functioning working locomotive that you don't have to do any fiddling with, and taking it away in one piece, as it were. That is a massive achievement, and you've all got enough time, you've all got capability, you'll all be bright students, apprentices, or young engineers to be able to achieve that, hopefully. Fiona, do you have a slide of the agenda? I wonder if you've got that. I know I've sent you some slides, but I wonder if you could pop. I don't know if you've got the next slide showing. Oh,
I don't have the agenda, unfortunately. But I'll just pop that in the chat box, and then we can go over that as well.
Because what we want to go through, I've got some slides on electrical machines which I'm going to share with you in a bit, but I don't know, Tom, did you want to go through anything in particular about mechanical or the mechanics of the competition itself? Because we've got kind of 3 items. Let me just check, is it in the chat?
Yeah, I don't have any sort of specific slides, but I'd like to talk about a little bit about reliability and trying to build reliable machines as well. I think that's a key part of the competition, is getting there with a reliable locomotive.
Yeah, so let me just I'll get my copy of the minutes, sorry, the agenda. Let me just bear with me one moment. Oops. Oh, right, hang on. Right, there we are. So in your in the chat now, there should be a copy of the agenda. So we're looking at overview. The first part is overview of the challenge at Stapleford, and there's 4 items there. We just want to talk these through. So when we get to the bit about electrical machines, I'm going to show you some slides, and I'm happy to lead this, Tom, and you just like chip in where you want.
Yeah, sure.
So the overview of the challenge at Stapleford. The first item there is on pre-testing. Okay, so our advice is to make sure that your locomotive, and you have to do this because you have to get your locomotive signed off, but you need to make sure your train has had an extensive period of pre-testing before the competition. So obviously the competition is in June. So if your locomotive has, let's say in May, if it's run successfully for an extended period of time, then that's a really, really good sign, because that will give you an opportunity to do all the sort of shakedown testing. You find the bits that kind of fall off or don't work quite as well as you or as well as you thought would work, and you can iron out all of the problems. So this is a big thing for the rail industry in general, is about understanding, trialing and testing of systems to make sure that when they're deployed in reality that they work well. So based on some reflections of how we've run the teams at University Birmingham in the past, I'm kind of a mentor for the team, and one thing that I've set up on a couple of times is some sort of exhibition or demonstration of the locomotive well before the challenge. So one good thing to do is for you to maybe say to your bosses, the senior management team in your organisation, we would like to demonstrate our locomotive in May. Can you come along and have a look at it? And then that puts in into your time scale like a clear time frame, a clear deadline for you to have the locomotive working. And if you then do that with senior management, you'll have that motivation, added motivation, incentive to demonstrate to them that you've built the thing early, you've built it on time to budget, and so on and so forth. So that's a key thing for you to focus on. Is pre-testing, and I think pretty much every locomotive that's won the competition has arrived at the test site with virtually nothing, no issues. They arrive, the team unload the vehicle, switch it on, do some fiddling, and then it's ready to go, and they don't need to do any engineering interventions in the medium term to get it running. So pre-testing is vital for a successful competition. I also think in this is again anecdotal, but based on previous years, sometimes teams will turn up with a locomotive which is still half designed, and they basically arrive onto the test site with quite a lot of engineering still to be done. I think that's it's a high risk strategy, and this is why pre-testing is really essential, is because then that focuses your mind earlier than on the actual test day and challenge days itself. So make sure you do that. You don't want to be turning up on the day where you've got to go and rush down to Halfords or something, or some electrical supplier or whatever, to find a part that then you hope to fit to the train, and you're drilling holes in things and using gaffer tape and zip ties to try and bodge the thing together. That has happened in the past, and although the whole weekend can be an overall positive experience, it's equally really stressful for you then arriving in that, and you'll also be under the spotlight of the judges and also the visitors and the guests that come along and see it. And believe you me, I don't think it's pleasant working in an environment where you've got people kind of peering over your shoulder saying, oh, I don't think you should do that, you think you should use this and that. And people, although they might be well-meaning, they could be it could be quite disruptive. So pre-testing is absolutely essential. If you don't do that, then you're setting yourself up for a big problem. Again, going back to thinking what happened to University Birmingham teams in the past, one year we didn't, the team didn't turn up, well, because in the days before the challenge, we had a fundamental failure of the locomotive, and the decision of the team was not to go with a broken locomotive trying to fix it publicly. with that high risk. So they decided not to go, and that was because they hadn't done enough pre-testing and shakedown, because a week later, with another week's worth of time, they would have been able to fix it. So yeah, pre-testing, really a good thing to build into your schedule. Absolutely. So everyone should do that. Right, the next item on there is unloading. So there's a protocol for unloading, and you have to do a method statement and so on for how you're going to unload and unload the vehicle up and so on. I think this is really again, it's a very vitally important part of how your team operates, is how you load the vehicle up into whatever you're using to. Oh, Felix waiting to ask a question. Hello, Felix. Do you want to say hello?
Hello, Stuart. It wasn't actually a question. Just to reinforce the pre-testing issue, the most successful year of Birmingham University was when we actually built a piece of track in the middle of the university and did demonstration runs for an open day. And the side effect was that we made about £1,000 for railway children by charging people to sit on our train. And so that's even better than having a senior manager standing in front of you. It really makes things work.
Yeah, absolutely. Yeah, that's a really good point. So having that pre-testing booked in well before the actual thing, and because what we want from the actual weekend is for you all to kind of rock up, unload your vehicle safely, put it on the track, turn it on, check it works, and then go and sit and enjoy the sunshine and get ready for the actual challenge events themselves. And I think you can all achieve this, and but provided you've got to get things like the pre-testing and project management all sorted out well before. I've got some.
And I just on the unloading side, Stuart. Most people end up hiring a van for that purpose, and you have to make absolutely sure that the people who hire you the van understand that you do need the tail lift. The tail lift is not an optional extra which you just get or not. We've had people who turned up where the van turned up, it didn't have a tail lift, it was the wrong size, and it made the whole process absolutely horrendous when they came on site, because I'm usually there with Bridget to sort of help with that process. And if you don't have a decent tail lift and you've designed your system to work with the tail lift in mind, then you're going to be stuck. Yeah.
So just to some more points on on unloading. The first time you move your vehicle shouldn't be when you go to the test site. So I think there's a real skill involved in packing up your vehicle, knowing what size you need, how and you need to work with your health and safety in your local organisation to understand about strapping things down in the vehicle and doing it in a tidy fashion. So some years the team at University of Birmingham took the train lots of different places, but by the end of it they were really slick in terms of loading up the vehicle, unloading it, having a list of equipment, and doing things in a structured way. So it's not like packing. Well, it's kind of like packing for going on holiday, but on a bigger scale. You'd be surprised at just how tricky it is to actually load a vehicle up properly and safely and strap everything down in a good manner. So it would help if you have a go at moving your vehicle from wherever you're building it to somewhere else by a practice loading and unloading.
What we have seen in the past as well, Stuart, is teams using flatbed lorries with a hoist. But I think you need to let the railway know if you're going to use that method, because obviously there's height restrictions and They need to know about, you know, if you're going to use a long lever arm to move the train across onto the track. But you know, there is other options other than just a van or a trailer.
Yeah, like for example, the other issues you might come across is things like Luton vans with a tail lift often have a load capacity limit of 500 kilograms, and if you have a team member that's standing on the platform with equipment, you know, that means the equipment's only, depending on how heavy your team member is, but you look, two team members could knock off 200 kilograms from what you're able to put on your tail lift if you have to have them on it while it's been operated. So things like this, you need to think about the loading capacity of the vehicle, how heavy your equipment is, and so on and so forth. But it is a really important thing to get right. Unload maintenance and refueling challenges. I don't know, Tom and Felix, I guess you're better placed, closer to the action. Do you want to comment on the maintenance and refueling challenges?
I can have a start and then Tom takes over, I guess. The maintenance challenge is basically you have to remove a wheel set, a driven wheel set, and then reinstall it. And you sort of think about that and you say, oh yeah, that's not too difficult. When you see an absolute set of experts doing it, they take about 30 seconds. And they stand to it. So you basically are allowed to go. Somebody says go. At that point, only 2 members of the team, I think, are allowed to do the job. So you have to lift the vehicle, you have to remove the axle, and then you have to stand back and show that you've done it. The judges then look at it, and if they're happy, then they allow you to put it back together. And the timing of that is extremely valuable because basically the best team, the fastest team gets the most points, of course, and the times are very, very short. So if your system is designed that you have to do lots of things of taking off, then you're in big trouble for the maintenance challenge. You should really only have to undo a couple of bolts or something like that, and then take it out. In terms of refueling, if you have a battery system, then you may want to change the batteries because that's the fastest way of doing it. If you have a very fast charging system, then you have to understand that the power supply at Stapleford is not going to do you 100 amps at X thousand volts. It doesn't. So I think, Tom, do you want to say something more about the refueling challenge?
No, only from a sort of safety perspective. I mean, I would encourage you all to have a proper risk assessment prepared, so you can share that with the judges prior to taking part. So you know, we can see your risk assessment and we can see that you've considered the procedure that you're going to follow. I think that's probably the best words of advice I can give is, you know, when you write these things down, you know, you've had to think about it, and then it's easy for the judges who are monitoring the challenge to understand the procedure you're going to follow.
Yeah.
If anyone's got any questions, just like stick them in the chat or shout. Turn your microphone off and shout. That's the next point. I think we will all probably have some comments on this. If I go first, understanding all of the rules. So I got some slides later, as I already mentioned. I think one of the things is important is you're all parts of a team, okay? So no one is doing this as an individual, and I think one of the important things early on is for how you are working as a team. Is to understand the different types of people that you all are, and some of you will be kind of really organised and like to do things to a deadline and like to read all the information. Others might be a bit more haphazard, but come up with novel and innovative ideas, and struggle kind of focusing on stuff, but equally can, you know, add contributions in different ways. And I think and some of you might want to do electrical, some of you mechanical, some of you, you know, systems and control and software. One of the bits which is vital for having a successful team is to have somebody or a number of you, a small number of you, who are completely familiar with all of the rules and regulations and paperwork and all of that side of the system and then the competition. Now, it's important to identify somebody who's got a natural tendency when they're reading, you know, an instruction manual, is that they read it cover to cover and want to know every single detail. And those that, if you get someone like that in your team, they can help you with all the paperwork and understanding all of the rules, because I'm sure you'll have people in your teams which will just like glance through stuff and then charge on and carry on and make it. That's not that they're not doing a good job, but I think it's important to reflect on the different characters that you've got in your teams and make sure that you've got somebody who's on top of the rules and knows what is required for all the challenges, and so on and so forth. And just to emphasize another point is one of the, well, when Birmingham has done well in the competition, a common feature is we've had really good project managers in the team, and they're the ones that kind of drive the project forward and understand all the time scales that are involved. And I think it's important for you to know who's good at that and who's not good at that. So I'm completely rubbish at project managing myself and do everything at the last minute, or, you know, when somebody gives me a deadline, that's sometimes when I start working on things. So try and, you know, understand the strengths and weaknesses of your team members, but you got to find that person that is going to say, right, my role in this team is about understanding the rules, the paperwork, and managing the project. I think that they can kind of go hand in hand, and they might not actually do any, you know, engineering themselves, but they'll be vitally important for the success of the whole project. to illustrate that with another anecdote, so my team at the University of Birmingham, we worked with Porterbrook to develop a Hydroflex project, which was really a much bigger version of the Railway Challenge, where we introduced a fuel cell battery system to run a 140-ton class 319. So it's exactly the same process, but with a couple of extra zeros on all the power equations and so on. We did that project in just over 6 months of real engineering time, and we had this outstanding project manager that would beat us with a big stick, like on a daily basis, saying, you need to do this, you need to get that done, we need to buy this, we need to do this bit of paperwork, we need to do that. So that he was really good at driving the project forward and making sure that we met deadlines and understood the sort of time frame of everything realistically. And I think the other part about sort of project management, that if you get you need a good project manager, but another really important part of having a successful locomotive is building it which to a level which is good enough. So this is something you might be wanting to make a perfect locomotive, but making it good enough is more important in terms of being a successful locomotive in the challenge. So sometimes you come up with engineering solutions for a particular problem, and you need to pick something that will work well and reliably, and you can implement it in the time scale that you've got, and it's cost effective, and it might not be the best, most optimum solution or lightest or whatever, but as long as it's good enough, then that's fine. You can tick it off and do it and implement it. And actually real real engineering projects are often like this, because we don't need to have you know, the phenomenal piece of engineering. As long as it works and it's good enough and meets the budget and meets the specification, then why make it any better? Because we don't need to. That eat into your time and your budgets and so on.
Yeah, I mean, I would add to that, you know, just think about the spec of like things like motors. You know, do you need 2 motors? Can you get away with 1 motor? You know, really understand the tractive effort that, you know, you need to get up the big gradient at the track. And one thing I would add is the balance of your team. You know, Stuart covered most of it, but I would just add in terms of balance of skills. What we see generally is you know, a very heavy bias towards the mechanical side in the composition of the team, and then at the competition weekend there's some sort of challenge around the control system or software, and you're very dependent on one single person, or that one single person is away doing an exam and isn't able to attend the weekend. We've seen that in the past, and the loco won't work. So, you know, really think about the composition of your teams and the skills that you have and that you need, and make sure you're not dependent on just one person. You know, make sure you're sharing the knowledge around the team, and that, you know, you're able to do most of the tasks between yourselves.
Just that's triggered another thought, Tom. So
okay.
When one thing's important is like procedures, so how you operate the locomotive. So as Tom says, you don't want to have the information contained in one person's head about how to turn the software on or the control system on. It needs to be documented so that different members of the group can operate the locomotive safely, with and you have that fallback. If person A isn't around, you can get person B to do it. And to give you an example, again from Birmingham's team, one year the judges said, can you move your locomotive like 5 feet towards the left or something, and we had like 90% of the team there, and none of them knew how to get off the parking brake. And it was quite embarrassing that the person who knew how to release the parking brake was in the toilet or something. And so single information that is stored in a single person's head is a problem. So it needs to be written down in a manual. So a number of people should be proficient and trained up in certain procedures in terms of like starting the locomotive, stopping it or whatever, shutting it down or whatever. So I think those processes, if you document them and write them down, it'll help you enormously. And again, this is if you've got a, you know, the way to think about it is have a look at a YouTube clip of you know, a pilot taking off you know, an Airbus. They sit there with a bit of paper and go through a load of checklists. They check everything, and it's all done on checklists and procedures. And trains are actually started in exactly the same way. So you should have the same methodology for doing any procedure with your locomotive. I know it sounds, you know, sounds obvious, but that's a sensible thing to do, and that goes for all sorts of activities. I mean, Felix and I both like cycling, for example, and there's a thing, you know, when you get on your bike, you test your brakes and your tires and your steering and your chain or something, and before you set off. Can
I chip in, Stuart?
Yeah, go for it.
So I judge the design competition, and in that they're supposed to include their various systems and procedures for doing all the things you're just describing.
Yeah.
And some are really good, and some almost but not quite silent. So it's a really important thing that they need to cover.
Yeah for that aspect of the competition, for sure, and it just makes things a lot easier on the weekend, because while you're doing stuff, if somebody is standing next to you, they might be sort of wanting to chat to you and you're starting your locomotive up. But if you've got a list of instructions in front of you, it's easier, even if you've done it 100 times, just to follow that recipe book in terms of starting your train. I think it's really really important. Do you have anything on rules, Felix? Anything you'd like to add, or Malcolm? No. So we go on to the next item then, which is
I don't know if we cover it. Only one other thing I'd say about building your loco is allow for the lead times of all your components, particularly, you know, machined components. You know, you're going to need to allow 10-12 weeks. Building your wiring harnesses and all your, you know, control electronics. You know, a lot of the control electronic equipment is in really short supply at the moment. So, you know, allow for really long lead times. You know, you probably want to be placing all your orders for a lot of your equipment already. Just really understand what the lead times are for all of your, especially on the control side. You know, we're seeing shortages of components in the real world. So, yeah, it's going to be no different for you guys when you're trying to build your locos.
This is the real world, Tom.
Yeah, exactly. That's what I'm saying.
It's
no
not
different.
fun. It's getting things right, and ordering things early is very, very important. And the simpler your equipment is, the more likely you can get the parts.
Okay. Should we move on to the mechanical part? And I know I bet Felix, you've got some comments, haven't you, on drive systems and so on. I think I mean, just as some observations and comments from me about the real trains, you know, I think the mechanical drive system from, you know, traction motor to wheel set is real work of art, work of mechanical engineering art. If you think what it's got to put up with in terms of, you know, taking power from a motor to a wheel set, which is moving around in 3D space relative to the motor. So it's a really difficult thing, and don't underestimate it. And Felix and Tom, I think, can give you your views on chain drives, which is almost a rude word, isn't it? Do you want to hand over to you, Felix? You can go through some of the issues we got with chains.
That's fine. Tom, do you want to say something first?
No, you carry on, Felix.
So the traction motor ideally would be basically the same as the wheel, so it would just be integrated in the wheel, and that is something which is done on tramways, it's done on some other trains, but for the purposes of the railway challenge, it's highly unlikely that you can have individual wheel drives. If you do, fantastic, I'll be very excited to see it. But if you drive an axle from a motor, then as Stuart says, you've got the problem that the axle moves with the primary suspension. I assume you have a primary suspension because the track is not brilliant, so you do need to make sure that your wheels stay on the rails. And that means you have to allow the axle to move a little bit. And then if you can have your motor effectively in a fixed position with respect to the rails, so that's in classical railway terms, and no suspension, then you'll probably stand a good chance of it staying in that place throughout the event. If your traction motor is fixed to the bogie and your axle is below the primary suspension, then you will get a great deal of differential movement between the two, and that may make a chain drive completely impossible, because the chain drive problem is that the slightest misalignment will lead to the chain coming off, regardless of whether you tension it absolutely correctly or not. The chain will ride up and fall off. I've seen so many chains fall off that I would be a rich man if I had £50 for each.
We saw quite a few last year. Quite a few last year had chain drives, and I think nearly every train-driven loco had the chain come off at some point over the weekend.
And the drive manufacturers will tell you exactly how to align the chain and how accurate it has to be. Now, the forces which are transmitted are not just the traction and braking forces, it's also the the shock loads. So the chain may well be perfectly aligned when you come to site, and then things move a little bit and the chain is completely misaligned. So any effort which you put into the design of a chain drive will be rewarded. If you have standard gears, so you have a small gear wheel on the motor, on the pinion, and you've got a gear wheel on the axle, then again you need to make sure that they are very well aligned. And if it's a nose suspended system, then you stand a better chance of the alignment being good. And the setting up has to be very accurate, because there's nothing worse to hear than the crunching of gears against each other because you got it slightly wrong. And that leads me to the keys and shafts. If you have to, when you fix a gear wheel to a shaft, or a wheel to a shaft, the keys are essential and they have to be right. If they are not right, then you get shock loading, you get oscillations, and you get all sorts of problems. If you don't necessarily have to use keys, because you can actually clamp things on with cones, and that is potentially better because you're aligning it better and you're holding it better in place. Every year we have people where a component fails. If it's a chain, then you may be stuffed because nobody else has the same chain. So you need to make sure you have got a chain with you, a spare chain, that you've got the tools to undo a chain and fit another one. So these are very essential questions. And if there's any questions from the teams, please do ask them now. And
it's the same for belt drives as well. So we see, you know, some teams turn up with belt drives, and it's the similar issues.
Yeah. The strength of the connection of the components which keep the two in line and parallel, those have to be much stronger than you possibly imagine, because the forces, the traction forces, and if you brake electrically, the braking forces and the track forces, etc., are very, very high, and that's a real thing on the mainline railway.
I guess you have to think about the traction challenge, don't you, where you start at the bottom of the gradient and you have to accelerate to full speed from standstill. You know, it puts quite a lot of force on the motor and the gearing interface.
Yeah. So and any spare parts which you carry along are probably going to save your life or that of somebody else. And the tools, make sure you've got all the tools with you that you need, and that they are in a well-organized toolbox so that you can find them. If you just throw all the tools into a big box and hope to find them, then that is not going to work. It's almost worth having somebody responsible for looking after the tools in your team. If you've got enough people, the tool master or mistress would be a very useful person to have. And make sure that you don't forget an attachment point for the vibration sensor. We may also do some other types of measurement that depends on what equipment we can borrow from, for example, the University of Birmingham.
Can I just start on the vibration sensor? Can you just the mounting point? Can you make it nice and accessible? Because we fit that before we go around and do the ride comfort challenge. So it needs to be fitted quickly. And you don't want to disturb your loco too much. You know, a lot of the teams you have to take covers off to fit the sensor, the vibration accelerometer. So just put it in a location that's accessible for the judge who's doing that competition. So you can just put it on, and then we can make the run. So it sort of needs to be fitted within seconds and removed within seconds.
However,
okay.
don't put it on a panel which is vibrating.
Oh, of course, yeah. Because
then you get oscillations from the panel. So it's the ideal place to fit it is on the main frame, but protruding outside your beautiful cover so that the judge can put it on easily and straight away.
Okay, any questions so far? They've all been quite quiet. There's 37 people been really quiet. I don't know we should worry about that or not, but
can I ask questions?
Yes, please.
We're from University Derby. When for the vibration meter, we want to know the how much space is needed, because it's magnetic. I remember last time, yeah, it just attached to.
Yeah, it doesn't need to be huge. It's just a small,
it's probably
pad.
About this sort of size.
Yeah. Okay.
Yeah, maybe the size of a 50p or something like that, a little bit bigger.
Yeah. Okay. Do we have any this vibrate? You know, this sensors kind of spectre, or could we are likely to try it maybe beforehand, if possible, that we can get a similar sensor for our own internal.
I'm sure we can share the spec of it.
Yeah. Okay. Thank you.
Any other questions?
There's one from James Hardy. He's asked, do we have dimensions for the vibration sensor? Don't know if that was covered or not.
Yeah, we'll share the spec. We'll share the spec for you now.
Okay, thank you. Sorry.
One more point. With your motors and the link to the axle, you have to make sure that the gear wheels which you're using are apt to the job, because sometimes you'll be told, oh, just use a plastic wheel or just use an aluminium wheel. You have to make sure that it can actually take the forces, and it's not just the traction and braking forces, it's the vibration and the shocks. The track has got its jointed track, so you will get exciting behaviors.
Yeah, and the alignment of the track. So going back to the suspension discussed earlier, you know, the alignment of the track. You know, it's not network rail. It's a bit all over the place, particularly in the station area. You know, and if we see derailments, it's up in the station area where you know, at the points and crossings, the track can really undulate. So just, you know, be aware of that. Make sure you've done your calculations around your suspension movement, and you're able to you're not going to derail on big dips in the track.
So there is a specification for the twist of the track, and don't think it's exaggerating. There will be bits of the track which are severely twisted, and the flanges of the wheels are not that big. So don't rely on the flange to keep you on track. You really have to make sure that the axle can move sufficiently to absorb twists. If you have a bogie and the bogie is not too long, then the bogie needs to be able to rotate underneath, to yaw underneath the vehicle, to yaw and drone.
Yeah, I think that's a really important point both of you made about you know, in the station area, and the track. When you look at it, to your eye, it looks okay, but then the rail vehicle goes over it, and one of the wheels lifts up in the air, and then doesn't behave like a wheel anymore, because then it just derails straight away. So I think understand. I mean, this is a big part of the whole challenge, is for you to develop an understanding of how rail vehicles move on track, and we're on the plane line, on the good stuff where you're moving quickly, it's not really a problem. It's the slow movements which often cause derailments, and you could say that's the same in the real mainline railway, as most derailments happen at lower speed on parts of the track which aren't level and so on, and have twists and unusual features. So just be aware. Think about that from the outset, is how your vehicles are going to deal with low track quality.
Yeah, and I'll touch on gauge as well. You need to respect the gauge clearances, because particularly around the axle area, The points machines at the Stapleford, they've got big metallic covers on them, and you know, we've had locos in the past that hit those points covers, and yeah, so make sure you respect the gauge clearance.
If you have a 2-axle locomotive, then the axle spacing tends to be quite big, and twist has a bigger effect than if you have got 2 bogies, and each of the bogies has got maybe 40 centimeters or 50 centimeters of axle spacing. Yeah. So that's quite an important point too.
Yeah, I guess most of you will go to the Stapleford site visit next month. You know, I think it's in a week's time or so. But yeah, make sure you have a good look around the station area. Look at the points machines. Look at the, you know, look at the track alignment. You know, make yourself familiar with what the conditions are like when you're there.
Okay.
Okay. Any other questions about sort of mechanical issues? I think Felix and Tom done a good job of explaining some of the things to worry about and to be aware of. But shout out or put a message in the chat if you've got. And equally, if we carry on, if something pops in your mind, we're happy to go back as we move on to the next section as well. So now we're gonna. I might show you a few slides. I've got some comments really on electrical aspects of the different challenges. Now, I'm guessing, you know, as this is an IMechE challenge, you all might have your hearts in mechanical engineering view of the world, but very, you know, these days, I think the boundaries between the disciplines of civil, electrical and mechanical, certainly for railway engineering, are kind of getting blurred, and you can't be one engineer that doesn't understand electric, you know, so you can't be an electrical engineer and say I've got no idea about mechanical, and vice versa, and the same for civil. So it's important that you have good electrical and electronic understanding within your team, and that knowledge then is shared amongst all of you. I think that's really important. So, you know, the regenerative braking element and the energy storage issue. So we need to well, you need to make sure that whatever motor and motor drive system that you develop can cope with turning the machine into a generator as the vehicle's braking, and being able to control that in a sensible fashion is important. And that regen energy has to be accounted for in the energy storage system, so you can account for the amount of regen energy for using later on. One other thing, I might just share a few. I've got a few slides I want to share. Let me see if I can do this. Oops. Oh, right. Not sorry. Right, there we are. Hopefully, can you see that? Hopefully. Yeah. It says parts to buy. So this is the things that you need for your trains, your locomotives, are motors, and the two main classifications of motors are alternating current ones and direct current ones. I would imagine that in the competition, the majority of teams end up with probably DC motors because they are kind of easier to control, and it's easier to buy a controller that will control a DC motor than an AC one. And DC motors are pretty good for regen. It's not that AC motors can't do it, but it tends to be that's the choice that everyone goes for. So you need to think about whether you do AC or DC, and both will work. My observation is that we tend to have more DC motors, I think, in the competition than AC. In order to drive your motor, then you need a motor controller, which is a bit of power electronics which will run your motor, and that will be, you need to buy that so it's matched specifically to your motor type that you've got. And then another thing then is how you control the motor controller. So the motor controller really is like a big amplifier, effectively, where it takes a smaller signal and then sends a big signal, i.e. a big signal which can deliver power to your traction motor. So you need something then to control the motor controller. Now this could be, this most simple device might be like a potential divider with a dial on it or something, but that's really rudimentary. I don't know if any teams have ever done that. So normally it's common to use something a bit more sophisticated, and several motor controllers will be able to use like things like CAN bus messages or other systems, control over Ethernet or something like that, USB cable to send a signal to your motor controller. Oh, you got a question, Felix?
No, but just on the same topic. If you use a very simple system or a very complex one, it may make sense to actually have a simple system in reserve if something goes wrong with your fancy kit, and certainly having just a potentiometer, you could survive with that. But more important is, and I think Stuart will probably agree with that, don't try to control the speed of the motors. You have to control the torque, because if you have two motors and one of them, they will always run at slightly different speeds, their wheel sets will be slightly different, and they will start to fight each other. One will try to drive and the other one will try to brake, because usually they have got two different controllers. So make absolutely sure that you control the torque, so that is the force and not the speed. And now you're not the, I mean, I know mainline locomotive designers who have tried to control the speeds of the different axles of a locomotive, and they have all failed. Basically, you say, I want this much torque, and then the motor will deliver that torque, and the other motor will deliver the same amount of torque, and you then get the speed which this torque can support.
Yeah. So just that's absolutely right. I think one other comment about your motors and your control, particularly your motors and your power cables. So you're going to be handling quite high powers from the motor controller to the motor, and you need to make sure the cables are properly specified. And one of the things that's important is a thing called bell testing your cables to make sure that the ends of the cables are connected to each other, the cables has got integrity, and so on, and actually how you connect your cable to your motor and how you connect it to the motor controller, whether you're using something like crimps or so you need a really robust way of connecting power cables to the devices. And similarly, any control cable has to be properly connected at the end. The worst kind of connection that you could be using is those kind of I don't even know what they're called, chock blocks. So if you've got a plastic chock block and you have to screw down on and clamp onto a bit of wire, if it's got a chance of coming out, it's going to come out. So these sort of issues cause lots of problems. Is you're operating in a high vibration environment. Your locomotive is going to be sitting on the back of a truck or whatever, drive into the place. It's going to be shaken around a lot. So one common cause of faults is loose connections and faulty connections. So somebody needs to know how to do that. And just to go back for anecdotally, in the University of Birmingham, we've got some expert people that are really good at crimping cables and performing, doing joints. And I remember once years ago, I had to go and I thought I could crimp something, and I crimped something, and the guy came along and said, look, that's rubbish, Stuart. And he just wiggled the cable and it came out straight away. So it's a real art actually doing cabling and loom making looms and so on, and make sure you've got somebody who's really good at it.
Yeah, a good reference standard, Stuart, might be EN 50155 is the European standard for control systems and harnesses for rolling stock. I wouldn't often recommend you read an EN standard, but it might be a good one for you to refer to, because it has some minimum sort of testing standards and minimum requirements in there for use of electrical equipment on rolling stock. So it could be useful to have a read of that standard.
Yeah. So
can you put the number in the chat, Tom?
Yeah, I'll put it in. Yeah.
Yeah, so I hope you can see the next slide. More things to worry about. This is electrical stuff, so it's an IMechE challenge. So and I think probably I know this is observational or anecdotal, but most of the problems we see on the actual weekend are probably electrical or systems. Can
I correct that, Stuart?
Go on.
Most of the problems we see are mechanical problems of electrical systems.
Okay.
It's the things which don't quite hold on, the things which have not been properly fixed.
Yeah.
And then you can't measure anything, the signal doesn't get through, and then people say it's electronics. No, it's not electronics. It's the mechanical bits.
Yeah.
I guess the same goes with the software, isn't it? You assume you have an issue with your software, but it's just you're not receiving the right signals back to your controllers.
Yeah. So in a Unreal Rail system, all the cables have IDs on each end of them. So that sort of thing, and color coding cables, all these things are important. The other thing you need to think about is whether you're going to get any electromagnetic interference between cables. So, if you had cables with signals on them, you need to think about how close they might be to any power cables and so on, because you could be introducing interference on your system, so that can be an issue. I already mentioned crimping and terminals. That's vital that goes to plan, and because it's a real headache if you're having to fault find. Part of your circuit doesn't work, you have to go through absolutely everything in order to find it often, and it can take quite a long time. You need some sort of cable schedule, so a schematic of your cable, so and how everything's laid out, what's connected to what, and so on.
An up-to-date one as well.
Yes, I have seen people arrive without one, and that was a nightmare.
Or an old one. Our system was like this, but now it's not.
Yeah, and I mean, it's that sort of thing, like you don't want to do bodge jobs. I mean, I know if you're making something in your house, you might bodge something, but we want like professional level engineering. So if somebody was to change something in your design, then everything has to get updated. So your drawings have to get up to date. You issue a new cable schedule, a new schematic, and so on and so forth. And then it has to be a representation of what the real locomotive is. This is how the real railway works. If you change anything on a train in the real world, then the drawing that represents that part of the train has to be updated, and it's logged, and you issue a new version of it, and it's all done correctly.
Jones was quite happy to move.
So far it's not.
I can hear background.
No, it's from that first stop line. Somebody's in the
Felix is getting booted out. Are you? He's in the right. Anyway, yeah. So this is you have to be organised, and somebody take responsibility for managing any design changes that you can have happening. Then things like fuses are really important. So if something was to go wrong in your electrical power system, you may have batteries or supercapacitors on your train. You need to think about what happens to if something was to go wrong. So a fuse is there really to protect the cable that from being overloaded. So you have a fuse that would blow and isolate a circuit. So you think about fuses, and then if something does happen on your train and a fuse breaks, the first thing to do is to try and find out what happened and why it broke, rather than replace the fuse. So that's really important. And then one of the things which is also important is understanding like earthing for your system and how you manage it. So the chassis or the frame of your vehicle is going to be connected to, that'll be your earth reference if you like, and you should have an earth strap to the wheel set, so then that's connected to kind of Mother Earth, as it were. But then you need to think about how your power system is run. Is it a floating power system, and so on? And then you need to be careful about faults that could happen. So a common fault with a floating power system is that it's a first fault where the power system would still work, where it is if one of the live cables was to come in contact with the frame, it would just then clamp that part at the same voltage as the frame, and move the other part in the other voltage in the other direction. So that might not be a problem, but it could be an issue. So you need to be very careful about those sort of things. We had a problem one year where an earthing point on a motor actually made contact with one of the live cables, and that what ended up happening with that locomotive is the return current from the motor was actually traveling through the earth system of the locomotive, and then at some point one of the earth cables just started glowing red because it was handling 70 amps through a small cable. So just think about how the current's going to flow around the system and what happens when things might go wrong. I think I've mentioned this, you cannot win unless you do proper project management, and again just reiterating that you've got to get somebody who basically needs somebody in your team who's going to wake up tomorrow morning sweating because they've dreamt about something that they've forgotten about, and they need to get it done today by by lunchtime. They have to do it. You need somebody who's on task and keep you running in a straight line. You cannot win unless you do all the paperwork. So all of the teams that win, they do absolutely every challenge and every aspect good enough. All right, so it goes back to that good enough. What are the minimum requirements that you need to meet for everything? If you achieve them, you've got a good chance of winning the overall competition. So a lot of the time the winners just are consistent and they do well at everything. They might win a few challenges, but they're good at everything, and they're not bad at one thing. So we already talked about testing, and we talked about getting your boss or someone to have a go at riding your train because you want to impress them. And I've already mentioned this about the documents, reading all the documents and any updates that come out. So somebody needs to be responsible for keeping the team up to date with the documents. It's not something everyone needs to read every day, but if you don't have someone reading the documents and familiar with all the rules and regulations and the requirements for the test and so on, then you will struggle.
Stuart,
yeah.
Back to fuses.
Oh yeah.
If you decide to have circuit breakers instead of fuses, then the temptation when you have a problem is to just push back the circuit breaker, and then it jumps open again. And that, so for circuit breaker is very easy to reset, but unless you know why it tripped, don't reset it, because that you can actually make the damage worse. And on earthing, if you have shielded wires for your control, you have to make sure that your only one end is earthed and the other end isn't, because you may send up loops which could actually cause you problems.
Yeah, I was
So
just going to suggest that
careful.
on the grounding, yeah, because grounding can be quite a complex subject, so you need to be really conscious of what you're doing on the grounding, and particularly on EMI as well. You know, like Stuart touched on it earlier. You know, don't mix. You know, there's some basic rules that you'll be able to find on Google. You know, don't mix your power in your signals. You know, cross them at 90 degrees. There's some really simple steps you can take to reduce your EMI risk. Twisted pairs on the power cables, etc. Yeah.
There are people who are earning an extremely good salary, basically just by knowing something about grounding and shielding. Thinking of Roger White.
Yeah. Yeah. I mean, it's sort of stuff that's obvious. I mean, but then a lot of people, if you've got a power circuit, and you have one cable feeding your motor and another one coming back from it, you need to keep those cables close together, because if you don't have them close together, you get a big magnetic field like in between them. So generally keeping cables as close as possible then reduces that factor. But if you've never come across the problem before, you might not realize that, you know, because when we teach electrical engineering and we draw a circuit, the circuit on a circuit diagram often has a big distance on paper between the positive and the negative, because we want to show them as separate. But when you implement that in reality, you want to keep the cables close together, because then the magnetic fields tend to cancel each other out a bit more. But put a big gap between them, and then you've created yourself a potential problem. So somebody who understands how inductance works, then, as Felix says, if you understand earthing, electromagnetic compatibility, inductance and capacitance in power circuits, you kind of got a job for life, as long as we need trains and power systems. And earthing is really complicated. I think one of the, go back to the fuse problem, when things go wrong, as Felix said, if it goes wrong with a fuse, then it's better really, because you've got some time to think, shall I put this fuse back in? and the fuses can be expensive as well, so that's another incentive for understanding what's happening. If you're blowing up a 10 quid or 15 pound fuse, then you might actually use your brain to fix the problem rather than just stick another fuse in until you happened on the right side.
You need to have spare fuses whenever you do come to Snapplefoot.
Yeah.
Spare fuses.
Yeah. And never be tempted to use, if you use the wrong fuse. Like, don't. If it's blown, it's blown for a reason. Normally, don't just get a fuse that can cope with a higher current. That won't work. Right. How are we doing? So yeah, I think we talked about this already. Like in your team dynamics. I mean, the other thing that'll happen, or could happen in your teams, is you have a massive bust up and you fall out, and you might have arguments and so on. So understanding human behaviour is almost as important as understanding and understanding the engineering, and the same in the real world is you've got lots of different types of people and different motivations of people and so on. So in a typical team, you have a mixture of organized people who are really organized and like organized stuff, unorganized, and you'll have extroverts and introverts and team leaders, followers and worriers and so on. I think a good team will actually have a bit of all of them in it. You don't want a team full of introverts or extroverts, or it's actually much better if it's diverse. Diverse in skills and everything else is really important. That will make a much better team, and for you to then understand how each person's skills can then be brought to the team to get the best out of it. And everyone's important then. So it's important, I think, is understanding that behaviour and equally people not getting fed up with the other person. So the unorganised people might be quite innovative sometimes. Maybe they'll come up with like a wacky idea that's actually really good. But the organised people might get frustrated by the unorganised people because they like turn up late and whatever. But everyone's got their own strengths and weaknesses, and it's good to try and not understand, have a bit of empathy and understanding, and that might stop people falling out, because it is emotion. I think one other thing, this is an emotional and challenging competition to get involved in, and you put a lot in, and I think only one team is going to win. But I think for me when I've mentored teams, obviously I want them to win, but I think for the real success is if you arrive with a train of locomotive that works well, and you do good, and you go home and it's still working, then that is a massive success. And that's what I think you should be aiming for, is to deliver a locomotive that's reliable, and it will do however well it will in the competition. But that's my recommendation, is to aim to achieve working locomotive that will not cause you a headache on the actual event. So
can I make one more point?
Yeah.
And that's about traction motor power and drive power. We've had in the past teams which selected the motor and the appropriate controller, and they did absolutely spot on. But what we discovered later on was that the manufacturer had actually been lying about the capability of their kit. And even during initial testing, nobody found out, because they were not testing on a steep hill. And as soon as you went on a steep hill, either the motor or the electronics blew up. And I can't blame the teams, because they were doing the right thing, they were using the right information. So making sure that you have a bit more oomph than you need is a good idea. And it's also a good idea to try and get some comments from people as to whether that manufacturer is actually good or whether that manufacturer is dodgy. Because these motors and drives are long lead items. Ideally, if you have 4 motors and 4 drives on the locomotive, you should be able to run it with 3. If in a perfect world, you would be able to run it with 2, but you might still want to take a spare with you. And it's not going to be it's going to cost 25% extra to have a spare, and that 25% may be very useful.
Mm-hmm. Yeah. Hopefully you can see that picture. We're aiming for the one on the right, if anyone's in doubt.
I don't think I've ever seen one on the right. They're generally more like the one on the left. Apart from TfL. TfL always turn up with a beautifully wired logo.
I was going to show some pictures as well, and they are quite good.
Yeah, so I mean, this helps with if you build something like the one on the right, it'll work, and you won't have to fault find. If you build something on the left, you probably have to fault find, and then it'd be a headache. So it's kind of yeah, if you build it right in the first place, so you can do fault finding, you probably won't have to, because you built it right. Whereas if you build it wrong, you'd be wishing you built it right in the
And
first
it goes
place.
back to the EMI as well. You know, you can imagine the one on the left would be a bit of an EMI nightmare. You know, you've got all your wires crossing, you've got nothing screened. Well, it might be screened, but you know, it might be completely useless just because of the way it's arranged on the
Yeah.
you know, within your system.
Yeah. So and that goes hand in hand with those cable schedules and so on. So that was, I just wanted to share a few notes there. I don't know if you got some pictures, Felix, you want to share, or?
Yeah, yes, I can do that. I'm just trying to see share content. Where is it? Oh, why can't I see it? Oh no, it's on the Windows. Yeah. So that's the one. Anyway, I think it starts with a sort of life cycle diagram, because anything which you do on the left-hand side, which is up here, is going to influence the success on the right-hand side. So the time which you spend here in getting the right system requirements, which are basically what the challenge is about, making sure that the system requirements are correctly allocated and that you design something which has a chance of working, that really, this is the point where you win or lose the competition. The manufacturing, you have to get right, but if you have got the poor design, then you will be doing the manufacturing twice or more. Once you go up to the right-hand side, you have fixed a lot of the things which you need. And so, because you've done it on the left-hand side, so things should come together reasonably well. So the other thing which is important, that when you actually do your verification, you go back and say, do my system requirements actually satisfy what the definition was and what the conditions are? Have I apportioned the system requirements correctly to my system? And then the design and implementation, have you actually done what I promised to do? And while you're working on the left-hand side, you have to think about how you're actually going to prove that this works on the right-hand side. So design and implementation should also think about installation. Apportionment of requirements should think about how you're going to validate that the system works. Then you come into commissioning, and that you should have a plan for that. What are you going to do in what sequence? And then you can say, actually, yes, everything's going well. And the operation and maintenance phase is relatively short for the Railway Challenge, but in many cases, people actually start with a locomotive which exists. And if they don't have the right documentation, they can't go back to it. Hopefully, you won't have to dispose of it. So, so that is understanding the problem on the left-hand side. That is implementing the system and then maintaining operation over time. And that's really, if you have the system working in May or April or early June, then you have to keep it working until the event. So this is a fantastic example of a really well-wired locomotive. It's a 2-axle locomotive. Surprisingly, it worked quite well. And this, if you can look up here, you can see that there is actually a hydrogen cylinder here. So this was actually the hydrogen Pioneer. But the wiring is not ideal. It's really quite problematic. This is a locomotive which derailed. So they're just trying to get it back on track.
Sorry, to
Sorry?
that go back to the previous one. So just to, so that on that locomotive, I can't remember which version of it. We one of the things we have is an emergency stop system on it, and not in the competition, but we took it actually to the facility in Northampton and NSAR to demonstrate it there, and we had an issue with the emergency stop daisy chain because the things were screwed in, so you had cables that had screw terminals, and then some of them were loose. It was a nightmare to try and find out what had gone wrong with that sort of system. So yeah, the connections are so important, because it just causes a massive headache if you have to fault find, and we did on that, and we were fault finding in a tricky situation, because we'd taken it to demonstrate it somewhere, and the emergency stop wouldn't turn itself off, so we couldn't start the locomotive. Anyway, sorry to interrupt, but that's
all right. That's all right. So this was a locomotive with chain drive, and the chain had come off, and you're actually blocking everybody else, so they had to immediately put it onto the onto the supports, so they could drive it away from the track. And you can also see that the lifting kit is at an angle. It's not well fixed. Well, there were more problems, but they're just putting back the support wheels. The locomotive worked extremely well, but you lose a lot of time when something like this happens. And you can see our ferocious judge on the left-hand side with her sun hat. You wouldn't want to cross her. And this again shows sort of some locomotives. The catapult locomotive arrived on site in a box with loose bits. Surprisingly, it actually worked at the end. But a nicely set up system on the left-hand side with proper connectors and everything makes life so much easier. Very nicely laid out power circuit on this one. And you can see there's a lot of connectors which can be released if necessary. Unfortunately, the electronic side was not so successful. You can see lots of loose wires, and that caused continuous problems. Lovely. Please don't. Not a single label on a wire. Circuit breakers which can be reset without thinking, not good. Isn't that a lot nicer? Every bolted connections which are properly bolted, and so on. I just loved it, so I had to take several pictures. Okay, there's one more thing to add to Stuart's comments about let me just finish this off. Where am I? Am I in the right place? Yes, back here. If you have regen and you use supercapacitors to store the energy, there's an important point. When we started the Railway Challenge, a small supercapacitor cost £1,000. Today, you can buy very large supercapacitors for a handful of pennies. That tempts you to buy a big one. Of course, a big one is more useful, a big one is better. It can store more energy. Now, just imagine you have a large supercapacitor and you had pre-charged it, because you have to, otherwise it doesn't work. So it's charged to 24 volts and you try to regen into it. And because of the size of the supercapacitor, if you put in the whole braking engine of the energy of the train, the voltage goes up by 1/4 volt, because the supercapacitor is too big. So if you want to do with supercapacitors and measure the stored energy, you need to demonstrate that the voltage of the supercapacitor goes up, and you need to demonstrate that when you try to drive the train with that energy, it doesn't go below, because otherwise you are cheating. So demonstrating successful regen is very difficult, and the big supercapacitor doesn't help you. It actually makes life almost impossible. And if you can demonstrate to the judge that you're really using only the recovered energy, then the judge is going to be happy and you're going to get lots of points. That's it.
Yeah, I got just another thing I don't think we touched on. So I thought about it as you were talking about the supercapacitor, is understanding the energy stored in the system during like an emergency stop application. So if you've got batteries and supercapacitors and motors that are permanent magnet motors, then as if you activate an emergency stop, then you really need to think about what's happening with the energy in the system and how that's managed. So in a supercapacitor, in electrical terms, we think of it, if you want to have a mechanical analogy, it's like a spring. So if you have a supercapacitor that's charged, it's able to release all of its energy in a very, very short time. So therefore, it's actually quite dangerous. So supercapacitor circuits need to have pre-charges to charge them up, because when they first switched on, they look like a short circuit because they've got virtually no internal resistance. So it's like a short circuit. So that can be a problem when you're charging them. But equally, when they're charged up, if you switch the locomotive off, then you need to have some sort of discharge circuit that allow the voltage on the capacitor to drain away, and through a kind of a rheostat, a resistor that just like dissipates that energy in heat. So these things need careful thought. Otherwise, you'll run into some sort of problems, and it's potentially dangerous as well in terms of like developing a fire or something going bang.
You want to ask the question about the fire safety rules? Just get your voice on, your microphone on.
Yeah, so there's a comment about the train cutting its power and activating emergency brakes. I don't know. Yeah, there's a comment about the tunnel. I don't know what. Do you have a view on that, Felix and Tom?
I'm just having a look.
Yeah.
The tunnel is big enough for you to walk along the train, so in that sense, it's not a problem. There's only one tunnel, and it's not so small that a person sitting on the train would be likely to. Because otherwise the train may stop on a bridge or in a tunnel. And I think if you write in your documentation that this is why you're allowed to have an emergency brake, then that's fine.
I think we've pretty much come to the end of our input, but we've got more time, so happy to stay around, aren't we, to answer questions.
I have got to go back to the meeting which I stepped out from. So
okay, yeah. So maybe we'll summarise then. Any more questions?
Was there anything else on your list, on your agenda?
I think we covered it all actually.
Okay. Well, thank you, everybody. I will be the person standing behind you in the summer if you can't get things to work, and so you don't really want that. And there's a very nice expression. The people you don't want to have on your team or helping you are the Viviers. The Viviers are people who say, wouldn't it be better if you? And in most cases, it wouldn't be better at all. Once you have got a good strategy and a good design, stick with it. Don't listen to the Vivier who says, wouldn't it actually be better if you put a steam locomotive in front of it? No, it wouldn't. That's an extreme example, of course.
Yeah, just to add to that anecdote, our team one year we had a team member who was tasked with dealing with those people. So if the team were all working and doing something, or so right, you can have a team member that's designed for public relations to go and deal with the people saying you should do it this way. And
essential. Okay.
Yeah.
See
Right,
you,
thank you,
everybody,
everyone.
and good luck.
Thank
and
you,
if you
everyone.
have got if you have got specific queries, then I think if you channel them through Fiona, we will try and answer them.
Okay.
Thanks, Thomas. Thanks, Felix and Stuart.
Thank you.
Just let everyone know in regards to the teams, if you haven't already, there is a site visit taking place next Wednesday. So if you haven't confirmed your attendance, please email myself or the Railway Challenge at IMechE.org. But thank you all for attending today, and
Bye.
hopefully we'll see you next week.
Yeah,
Bye.
thank you. Bye.
Bye.